Bismillahirrahmanirrahim. This is the last tutorial in our semester. It's about pollution, and we'll solve a couple of problems from sheet 3. So the main parameter in pollution that we will be calculating and discussing is the pollution load. This load just indicates the amount of pollutant discharged by an industrial facility. So this is in units of mass per unit time, and to calculate that we need to know the flow rate going out of the facility. So this flow rate Q will be in units of volume per unit time, and the concentration of that pollutant that we're calculating the load for in that waste stream. So the concentration will be in units of mass by units of volume. So volumes cancel out, and we're left with mass over time. Okay, this is the load. And just to remove all the writings here, L for short, load, is equal to Q, the flow rate, times the concentration. All right, there are some theoretical parts in the pollution chapter. These were discussed in the lecture. We'll only discuss the calculations in this tutorial. So the units for these three parameters are the load is in ton per day. This is the typical or standard unit we use in the industry. The flow rate for the wastewater stream will be in meter cube per day, and the concentration will be in milligrams per liter or ppm, part per million. Since we have a million milligrams in 1 kilogram, and if the wastewater concentration of pollutants is very low, so we can approximate the density of the waste stream to the density of pure water, which is 1 kilogram per 1 liter. So 1 liter of water will have 1 kilogram of water, which will have a million milligrams of water particles. So milligrams per liter or per kilogram is equivalent to how many parts per million of those milligrams are occupied or are pollutants actually in the wastewater stream. Okay, that's it. That's the only rule that we'll talk about. The three parameters here are the load, flow rate, and concentration. All right, so let's solve a couple of problems to exercise. Problem 1, if the wastewater flow rate from an industrial facility is 500 meter cube per day, and the concentration of the suspended solids is 200 milligrams per liter, calculate the daily pollution load of suspended solids. So the daily load is this is just a direct substitution. It's just an exercise for this rule. So pollution load is 500, and we'll keep track of our units so that it doesn't get confusing here. The concentration is 200 milligrams per liter or ppm, and we just need to standardize our unit to be ton per day in the end. So we'll just need a couple of conversions, or two conversions to be exact. Those two conversions, one from liter to meter cubed, or the reverse. So 1,000 liters is equivalent to 1 meter cubed. The meter cubed from here will be cancelled out with this meter cubed, and liter will be cancelled out with liter, and we're left here with only the number 10 power 3. Okay. Same goes for converting the mass. So the milligrams from the concentration units here will be cancelled out with this milligram, and we're left with tons. So in the end, we're left with ton per day as a unit, and the numbers are 500 times 200 times 10 power 3 over 10 power 9, or times 10 power negative 9. Okay. So the final answer is 0.1 ton per day. So the only thing in this problem, or in this rule, is the unit conversions to be made here. All right. So problem 2, if the pollution load for oil and grease is 2 ton per day here, and wastewater flow rate is 1,000 meter cube per day, calculate the concentration of oil and grease. So just direct substitution, but this time we have the concentration known and the load and flow rates. Concentration is unknown, and the loads and load and flow rate are known. So we'll just divide the load by the flow rate. Again, we need to adjust for the units. So the volumetric conversion, 1 meter cube is equivalent to 1,000 liters. So 1 meter cube and meter cubed here will be cancelled out. And for the mass conversion, a billion or 10 per 9 milligrams is equivalent to 1 ton. And this ton will be cancelled out with this ton. And the day per day will be cancelled out, and we're left with milligrams per liter, which is the standard unit for conversion. All right? So this will be 2 times 10 power 9 over 10 power 3 times 10 power 3, which is 10 power 6. So it will be 2 times 10 power 3, which is 2,000 milligram per liter, or ppm, part per million. Problem 3, if the pollution load for BOD5 is 5 ton per day and the concentration for BOD is 1,000 part per million, ppm, calculate the wastewater flow rate. So just need the water flow rate is the unknown here, load is known, concentration is known, same as the previous problems. We'll just need to convert the units. So again, ton is cancelled out with this ton, and liter will be cancelled out with this liter, milligram is cancelled with this milligram, and we're left with meter cube per day. And the multiplication here is 5 times 10 power 9 over 10 power 6, which is 5 times 10 power 3, and the result is 5,000 meter cube per day. The last problem, and this is actually where we apply the actual rule, not just direct substitution. This problem says the following table shows the wastewater characteristics from an industrial facility and corresponding limits of the pollution law. So this is the actual concentration in the discharge or the waste stream, wastewater, and this is our environmental law limit that we cannot exceed. So as we can see here, these 4 parameters are above the limit. We need to treat this wastewater stream so that we get those 4 parameters below the limits here. We don't need to treat everything. So if we have the BOD as 1,200 or 1,200 milligrams per liter, we don't need to treat the entire load for those 1,200. We just need to get it to this limit or just below it, so that we can discharge our wastewater, and it will go to central treatment plants to treat any waste streams within those limits. Okay. So if you know the daily industrial wastewater flow rate to be 300 meter cube per day, calculate the loads to be removed. So the load to be removed is, or treated, is not the entire load as we discussed. It's just the difference in concentration between the actual wastewater stream and the environmental limit that we need to take care of. All right, of course, times the flow rate, which is the discharge flow rate of our industrial facility. Okay, so let's just try one of these, and the rest will be exactly the same, calculated exactly the same in this column. So the first parameter is BOD, and it's just Q times the delta C in here, the difference between the actual and the limit of concentration. And since we have no space in this table, we'll just multiply by 10 power negative 6. This is from problem 1, if you remember. We multiply by 10 power 3 to convert from meter cubed to liters, and divide by 10 power 9 to convert from milligrams to tons, right? And the final value will be in the units of ton per day. So 0.15 ton per day of BOD. This is what we need to treat in our plant or our industrial facilities. So we need to have a treatment unit in there to only treat those 0.15 ton per day, and the rest will be treated at the central treatment plant for the waste stream. Okay, that's it. The same goes for all the rest of the parameters. That's it for today. Please let me know if you have any questions. Cheers.